Good morning, I'm Joseph Manawis from Group 6, here to report about radio receivers and radio parameters. First, basic function of a receiver. The receiver should be capable of changing the range of frequency to be received. The receiver should be also able to detect and convert the received RF signal to the original source information. And lastly, the receiver should be able to provide sufficient amplification. 6.1 Receiver parameters. Selectivity. Selectivity is a measure of the ability of a receiver to accept a given band of frequencies and to reject all others. Selectivity is also a measure of the extent to which a receiver is capable of differentiating between the desired information signals and the disturbance or information signal at other frequencies. Can be expressed as a bandwidth and the ratio of bandwidth at the receiver at some predetermined attenuation factor, commonly negative 60 decibels to the bandwidth at that negative 3 decibel half power points. Mathematically, shape factor SF is given by using bandwidth negative 60 decibels divided by bandwidth of negative 3 decibels. Percent selectivity can also be used by using SF times 100 or using the other formula, selectivity equals bandwidth actual divided by bandwidth minimum multiplied by 100. Bandwidth improvement. The noise reduction ratio is achieved by reducing the bandwidth. The formula for bandwidth improvement is BI equals bandwidth RF divided by bandwidth IF. For noise figure improvement, the formula is NF is equal to 10 log of BI. The minimum RF signal level that can be detected at the input to the receiver and still produce a usable demodulated information signal. Dynamic range is said to be the difference in decibels between the minimum input level necessary to discern a signal and the input level that will overdrive the receiver and produce distortion. The range of input power over which receiver is useful. Mathematically, the dynamic range is equal to 10 log of Pmax divided by Pmin. Fidelity is a measure of the ability of communication system to produce at the output of receiver an exact replica of the original source information. Insertion loss. Insertion loss is the ratio of power transferred to the load to the power at the source. Given the formula IL is equal to 10 log of power in divided by power out.
Anong gentle?
Sa history, si Neil
Armstrong. Si Neil Armstrong,
ang unang tao na manakatapak-tapak sa anong lugar.
Good afternoon, everyone. I will be reporting about the types of radio receivers. The first type of radio receiver that we will be discussing today is the tuned radio frequency receiver. Its advantages would include enhanced sensitivity and a simple circuitry. These advantages would include poor selectivity, instability, and requires multi-stage tuning. Shown in the PowerPoint is the block diagram for the tuned radio frequency receiver. First, the signal enters the antenna. which then passes through the antenna coupling network, and then it passes through 3 different RF amplifiers which amplifies the RF signal, and then it passes through a detector stage, which is the audio detector, after which it will go to the audio stage, which is the audio amplifier, and afterwards the output will be at the speakers. The second type of radio receiver that we will be discussing is the super heterodyne receiver. Heterodyning means mixing 2 frequencies together in a non-linear device. Its advantages is that it has good selectivity and sufficient image frequency rejection. However, its disadvantages would include moderate sensitivity, which compared to the tuned radio frequency receiver is poor, and it has a more complex circuitry, again compared to the first radio receiver that we discussed. Shown in the PowerPoint is the block diagram of the super heterodyne receiver. First, the signal enters through the antenna, which then passes through a preselector and an RF amplifier. The preselector is not shown in this block diagram, but it is somewhere in here between the RF amplifier and the mixer. Passing through the mixer, it goes through the IF amplifier, which includes a bandpass filter and an IF amplifier strip, after which it will go to the detector, which is again an audio detector, and an AF amplifier, which is also an audio amplifier. Then the output goes to the speaker. A loop is shown here in the mixer and the local oscillator. Shown below are the waveforms that is here on the block diagram. First, the RF carrier, the amplified carrier, after which, passing through the mixer and the oscillator wave, it becomes the IF carrier, the amplified IF carrier, the audio component, and the amplified audio component, which will be the output for the speaker. That will be all. Thank you.
Hello, good day. I am Austin Alag. I am here to discuss Lesson 6.3, Sections of a Super Heterodyne Receiver. RF section, or radio frequency section, generally consists of a preselector and an amplifier stage. A preselector provides enough initial band limiting to prevent a specific unwanted radio frequency from entering the receiver. Meanwhile, an RF amplifier determines the sensitivity of the receiver. The radio waves from various broadcasting stations are intercepted by the receiving antenna and are coupled to the stage. This stage selects the desired radio wave and enhances the strength of the wave to the desired level. The advantages of including RF amplifiers in a receiver is to have greater gain, improved image frequency rejection, better signal-to-noise ratio, and better sensitivity. Mixer converter selection includes a local oscillator and a radio frequency oscillator stage. The amplified output of RF amplifier is fed to the mixer stage where it is combined with the output of the local oscillator. The two frequencies beat together and produce an intermediate frequency called image frequency is the frequency other than the desired, which when mixed with the local oscillator will produce the same intermediate frequency. Fs here stands for the desired signal frequency, Fsi stands for image frequency, Fi stands for the intermediate frequency, and Fo stands for the oscillator frequency. Image frequency rejection ratio is the ratio of the gain at the signal frequency to the gain at the image frequency. The derived equation for it is IFFR is equal to square root of 1 plus Q squared plus the Greek letter rho squared, wherein Q is the quality factor of the tuned circuit and rho is equals to image frequency over desired signal frequency minus desired signal frequency over image frequency. IF section consists of a series of IF amplifiers and bandpass filters, and is often called the IF strip. Most of the receiver gain and selectivity is achieved in this section. The output of the mixer circuit is fed to the tuned IF amplifier. This amplifier is tuned to one frequency and is amplified. The detector converts IF signal back to the original source information. The output from the IF amplifier is coupled with input of a detector. The audio signals are extracted from the IF output. Usually, a diode detector circuit is used because of its low distortion and excellent audio fidelity. And lastly, audio section comprises of several cascaded audio amplifiers and one more speakers.
Hello, my name is Alan Matsio Lavario and I will be reporting single sideband receivers. So, BFO, which is beat frequency oscillator, it is necessary when you want to receive continuous waves or CW signals. CW signals are not modulated with an audio component. So you must provide one. The action of the RF amplifier mixer, local oscillator, and IF amplifier is the same for both continuous wave and AM, but the CW signal reaches the detector as a single frequency signal with no sideband components. To produce an AF output, you must heterodyne beat any CW signal with an RF signal of the proper frequency. This separates the signal is obtained from an oscillator known as a beat frequency oscillator. This is what a BFO would look like. First, it comes from the antenna, and then an RF amp, and then the mixer, and then the local oscillator will go into the mixer also, and then it would go to the IF strip, then to detector, then the BFO would go into that also, and then the last one is the audio amp and the speaker. So what is BFO written in the book? It is to produce a frequency input to beat or mix with the IF signal and result in a difference in some frequencies with the result. It should have at least the tuning range of 1.5 kHz above and below the center of the IF passband. So there are two types of BFO SSB single sideband receivers. This one is the coherent one, which was the same as the one that I showed earlier, and this is a non-coherent BFO SSB receiver, which is first it goes to the antenna and then the RF amplifier, and then it would actually go to the RF mix and then carrier recovery and frequency synthesizer, which is the BFO, which would go back to the RF mixer to here, and then IF amp and bandpass filters, and then to the IF mixer, which the BFO also is added into it, and then it would go again to a speaker.